Hello, everybody. This is Mario. I'm going to Mario. My name is Mario Gray. I'm going to do the Bootiful reactive testing for you guys. I hope what I have here is a fast PC, and let's see, what do we have? There we are. So, can everybody see that correctly? I hope that looks okay on your monitor. The name of this talk is a Bootiful reactive testing with consumer-driven contracts and Spring Boot 2. So if you're going to want to see the source code for the demo, you're going to want to hit this here link at GitHub Mario's code path Bootiful testing. Today's demo will be marked at as JavaFest, and then you can also check out this blog post that I like to show people. It's a little blog post about Spring Cloud contract testing in the cloud paradigm, right? So you have multi languages, polyglot languages. You have many people accessing your services, maybe your REST service from maybe Python or maybe Node.js or Ruby or Go. And you want to test them. But you don't want to spin the whole test. You don't want to run the environment, right? What this allows you to do is execute a mock of your services. I'm going to show that today. This article allows us to engage what it does on the broader sense for the polyglot community. So Marcin Grissesek has written this article a couple of years ago, almost 2 years ago, but it's a very good article. It's a really good way in in-depth exploration as well. Okay. Also, I'm probably going to talk about things that we're going to do for the coding aspect. So the first thing that I like to talk about in my talks are reactive and what a reactive gives us. What's the purpose of reactive programming? Why? Functional, why is it flow control? I'll show that to you in the code. There's test-driven development, which is a major part of this demonstration is test-driven development. So I'm going to talk a lot about that. And then there's test slices, which is what are Spring test slices? How do they work? And I'm going to show that in tests as well. But the Spring Cloud contract is probably the biggest part of this test. And I'll show you why. It's very important if you've ever worked in a team with lots of languages and lots of people writing service code and people writing client code. You'll know why Spring Cloud contract works very well between teams especially. All right, so we're going to get into some reactive and TDD basics next. I'll just explain it in one slide. The things that you will need to know in order to make any sense about the source code that you're going to see. And the first thing is the publisher implementation for reactive. If you can tell that there is a publisher implementation, that means it's the base class for the Flux and Mono. A Mono is a stream. A Mono is a publisher. A publisher, it represents a stream of data. And that Mono says I have one thing in that stream or nothing in that stream. And that's it. A Flux is a stream that says I have nothing or I have the entire world. What's in the but basically it means it has more than just one thing. And so the difference is, why would you use a Mono between a Flux? Well, imagine HTTP. It's a very request response oriented system. You wouldn't have a Flux of anything in an HTTP request response. And therefore, when you're talking to HTTP, you're actually using monosemantics. You're saying, okay, well, I'm going to send a request and I'm going to expect a response. The response will contain a lot of data, but that's abstracted at a different level. Okay, so then the biggest and the most important thing about reactive is that it has back pressure. And this is a concept that you don't have in other systems. You don't have this in your, for instance, your standard asynchronous classes, right? So you can't say, I don't want to execute in events. I only want to execute in events. I want to request in events, and I will execute map against in events only. And that means that a consumer can then say instead of giving me the whole world of number of a number of digits, say of 1 to infinity, one server, one request can say, give me 10. And then another server can say, give me 10. And then that way you can fan out the processing across multiple hosts. This makes reactive a very good programming decision when you're dealing with multi-threaded code. Finally, in order to make this all work and to make it look like something, and to make a source code that people are going to want to engage, people are going to want to say, hey, I want to work on that. I like to write tests, and this is where practice TDD comes in. So practicing TDD means I'm going to write tests that fail first. That is, they won't work. But I'm going to go from test directly to production. And then finally, I'm not going to write more production than I need. I'm only going to write a little bit of code. Just enough code to satisfy anybody who needs, well, I don't want to write more code than I'm going to have to test later on. And then repeat. Write as little code as possible, fix and test in production, and everything should be good, hopefully. This is also embodied in Bob Martin, the co-signer of the Agile Manifesto. He talks about, well, TDD, for one thing. He is the guy who kind of espoused the real tenets of TDD, why it's used and why and he's vehemently defending it, how it works, and why it's good. And I think it's like your dentist. I can say, yeah, it's kind of like the dentist. One is you're not allowed to write code in production unless you can make a failing unit test pass. Unless you can make the failing unit test pass with writing more production code. Number two is you're not allowed to write any more production code or any more of a unit test than is sufficient to fail. So eventually I'm going to write enough code in tests that it will just fail automatically on its own. And then I'd have to go into production. And then three is, like number two, don't write any more production code than is sufficient to pass that test. So we have those three things. So let's move on with that. Actually, let's move on with that. Let's just start coding. And then there's one place that I like to go to, and that is a website that we all know about. I'll open up a new tab, and I shall go into here and type start.spring.io. Okay, so what do we have here? We have a tab. Don't worry about that. We just have more of those little bookmarks there that are jamming up. We're going to write this in Kotlin. What I want to do is use Spring Boot 2.3.0, and I will call this calm demo, artifact Java. Well, how about com.demo.java first, and service, Java first service. We'll make this a jar file with Java 8, and then we'll generate that. Ooh, not yet. We're going to need some dependencies, so let's add a dependency. The first dependency I want to add is called WebFlux, and this is the Spring Reactive Web Stack. The next dependency I want to add is Reactive Mongo, because I want to test, I want to test the database. I'm going to also add an embedded Mongo. So we're going to add that. Oh, I could have used the press the star key, the extra key for multiple editions. I'll try that later. The final thing I want to add is something called contract verifier. Cloud contract verifier. This is for making TDD level software. This is what we're going to talk about a lot in our test. So those four components are all that I need. So I'm going to hit generate here, and now I have services 3.zip. And that's fine. So let's add a new window and drag our window down here. We can. Wow. Okay. Oh, it's a whole desktop. I see. Well, that's gonna be. Ooh, that's weird. Let's move that guy down here then. There you are. Yes. Now let's go to a workspace and let's go to Bootiful testing, and that's where I normally unzip everything here. Let's create another entry, Java Fast 2020, 2020 unzip the service. Okay, so now we have our service. We're going to open up IntelliJ in here. This will take a second because I use IntelliJ rather than a normal human being who would use probably Visual Studio Code. That's a good idea nowadays going forward. But give it a second and it'll load up, and I will actually need to kill that window. Goodbye. Yeah, there we are. Now we have a zoom window. This is going to basically take possibly Meet code, a faster compiler for things that are not written in Java. I believe that I hit the limit of CPUs. I have maybe 4 CPUs, maybe 2 CPUs on this one computer here, and luckily it can handle the brunt of Zoom calling IDEA and Chrome at the same time. I got to give it to them; they're pretty good. So what we're going to do is use service application tests. We're going to use this as our very first test to scaffold the regular test. So what I want to do is, I don't want to do anything too heavy to this guy, but ooh, hi, there you go. Okay, so this is a Spring Boot test. Although I'm not going to use Spring Boot test, I'm going to use another stereotype of Spring Boot test. This one is called Data Bongo test. And this is actually a test slice. So a Spring test slice basically declares only a piece of your application context that gets loaded at startup. So if you're used to using Spring, you know that the application context usually will auto scan components, and it'll find every little bit and nook and cranny of componentry that you've set up. Now, you don't want that to happen in tests, because that means that your application test will take a very long time, and that's not. And also, you're testing things along with that test for the ride. You don't want that. You want to separate as much test as possible, kind of like a sandwich. So if you think of a peanut butter and jelly or a bologna sandwich, or maybe a hot dog, you have your bread, you have your meat, and you have your condiments. And your cheese. Usually you have cheese. And in this case, the data could be the meat, but we're going to take just the meat out, and we're going to only test the meat. So I want to taste the meat. I want to see the meat's any good, and I'm going to make sure that I only test the meat and nothing else. So this annotation is used just to test on features that focus only on MongoDB. So this is a vital component. The next thing we're going to do is write a test, but it doesn't say context loads. It's going to be should, save, and find. And in Kotlin, it's fun, which is function definition. And then I learned some really cool techniques, like being able to backtick a method and say that method can have now any explanation for what it is. It can have any string in there. I love that. So I can say val save equal, actually val, what are we going to test? We're going to test messages. Message equals message. 1L, so that's the ID from Mario, to Luigi. And then it's like hello, I guess. I think that's usually how a message works. So we don't have message. And I think we need to, oops, there we go. There we go, create class. So we're going to create that in production because we just found our first error, which is that message wasn't there. So what we're going to do is, rather than define a class called message, I'm going to create a data class called message. And that's going to allow me to say, you know, that's it. So basically, the data class in Kotlin is kind of like a case class, and in our other language called like Scala, where we have a single definition for a set of properties that we just want getters for, no setters. We want constructor, but no setters. We don't want to maintain state at any point in time after construction. So I'm going to take that message and I'm going to say, well, I don't have anything to store it in. So the first thing I'm going to need to do is auto-wire something. All right. So what I'll do here is I'll say private latent var repo, and the repository is going to be a reactive Mongo repository of of type message and of type I guess ID type will be long. Is that? Yeah, I guess it's long. And so it's going to complain, yeah, I don't have anything like this on the class path right now. And that's true. There, IntelliJ complains for me, and it tells me that there's something wrong, that this particular type of component doesn't exist anywhere. Not yet. But that's not a compilation error, is it? That's just an IntelliJ error. I could still run this and it'll work. No, I can't, actually. And I can still run this as long as I don't access repo, and it'll work. Now, let's move on. Now, let's say repo.save message dot then many find all. Okay. All right. Well, let's call it Mongo stream. So how about save find RW read write stream. There we go. We're going to create a single stream composed of two streams. So the first thing was I said, hey repo, go ahead and save these messages, and then complete saving, right? And then mini is not part of repo, but it's part of the flux. So actually, I should make this better, more explanatory. I can say repo, how about write stream? Save message, and then value read stream. Find all. How about that? Now you see concretely what's going on, and you know you have two discrete streams that are that have not executed yet. However, I will compose the two streams so that stream A flows into stream B, and we get the output of stream B only. So it will be like A goes to B equals something like that. Okay. So value composed is equal to flux.from. So we're going to say, hey, give me a read the stream from here. Give me a publisher from our write stream, and then mini, which says once the write stream is complete, don't pass the answer down. Yeah. So do not pass the answer down from the write stream. Then call the read stream and pass its answer down once it's complete. So this write will complete. We will throw away its answer, and then read will then complete, and we will take its answer. So we only get read's answer here. Now, in order to test that, how does that work? Let's try testing it. Step verifier. What is the step verifier, and why do you need it? Well, it's a good question. The step verifier is, let's go into the source code and see what Arjen Potsuma wrote. And it's really succinct. It says a step verifier provides a declarative way of creating a script for an asynchronous sequence. So you express what you want out of that stream, and then the step verifier will trigger the stream. It'll cause your stream to emit data. It'll subscribe to it. It'll execute those expectations, and then it'll finish the stream as much as possible. It'll once it's finished, you're done. Now, if anything accepts, if something happens, I'll use assert next, and then I'll use assert J, well, which comes with Spring Boot. Has no fields or properties. Okay, has field or property with value, and we'll say that ID is our field, and it should have a value of 1 long, and that's it. So what's going to happen is if that assertion fails, then assert fails here, and our step verifier tells us. So from this point, we can say verify complete, but actually verify complete is compounding of expect complete, because any reactive stream emits a signal. And that signal may or may not get emitted for a number of reasons, usually due to programmer error, or perhaps the HTTP didn't, perhaps the thing that was subscribed to the stream didn't expect there to be a timeout at all. In any case, this could happen. Expect that you get a completion signal, otherwise timeout after 1 second. That's what that says. However, I don't need to worry about that here. So I can say verify complete, and that just says, okay, just make sure that you got a completion signal, and that's all. So let's execute. Well, actually, let's not execute this yet, because we know we have an error here. We're going to want to create that. So let's go back in here and say interface message repository, and it's going to be a type of reactive Mongo repository itself. So this will connect to MongoDB on its own. Spring Boot's set up to automatically find your reactive Mongo repositories, know that you have a Mongo repository, and say, hey, you need a database. How do you get your database? Well, remember that whole idea behind using data Mongo test. What this also does is it'll set us up an embedded, it'll look for an embedded database. There's a annotation in there that actually goes out, looks for an embedded database on the class path. And as long as an embedded database is on the class path, it'll use it. And that's what we get out of the flat doodle dependency here. So this guy here will be found on the Spring auto configuration starter. The Spring starter Mongo and embedded database will find it, and it will go, oh, okay, I have an embedded database here. I'll launch it, and then I'll connect to it, and then I'll tear it down after the test. And that's what happens. So it's you have the embedded database scanner within the Spring test framework. Also works for databases like Redis and Cassandra, and maybe even I haven't used it yet, but possibly I hope JDBC. But I know we just got our reactive RGDBC driver out, so maybe. Okay, so we're going to run that test, the should save and find test. Although I should probably continue, because I know that the compilation phase may be taking more than the time that I want to give it. So let's say that passed. If it doesn't pass, we have a very good reason to subscribe to a real test post-mortem. That is, that test should have passed and it didn't, and you know why. Okay, so we're going to call this REST tests, and the reason why is we're going to write a REST controller in Kotlin, and yeah, I'll add that to Git. So we're going to call, okay, great, class REST tests, and what we're going to do now is, remember the whole idea that we wanted to create, we wanted to slice our sandwich. We wanted to take slices out of our sandwich. We tested the meat, and we know that the meat is good and it works. The next thing we want to do is we want to taste the bread, the real delivery vehicle for the sandwich, and that's HTTP here, at least for me. So I'm going to go ahead and use at webflux test. Okay, so we're going to use webflux test. Now, this looks for many components that are part of your web stack. Okay, I'm not going to use any of those components. However, if you do have controllers and you have message mapping, it goes and looks for those. If you have REST endpoint, it'll look for that too. I'm going to show you something that almost makes it so, because webflux test helps us with the auto wiring, and its main job is to help the user to understand and to grapple with the idea behind auto wiring in Spring. We have components and we have a web stack, and we want those two things to go together. However, when we're testing them, we only want like some of it. We don't want everything, right? And well, I'll show you. I'll show you how much I can give you right now. Okay, so this is what flex test, and what we'll do is private late init var. Actually, I can go back here, and I can steal that guy. So I'm going to go back and steal him. I want that repository. But rather than auto-wiring that repository, because I don't want to auto-wire it, I can't. It's not going to get found anymore. I'm going to mock bean it. So I'll say, okay, mock bean it. Now you have a mock of that repository. And we're going to need to set it up for all. And then we're going to say private set up. And setup is going to do something. Private fun. Okay, so private fund setup. Okay, so the next thing we're going to do is we're probably going to want to do something like bdd mockito dot. Give it a second. Oh, it already. Okay, it already like. So I want to give it a stream, and I can say flux.just. I want to initialize a stream with elements. And flux.just allows you to do that. So flux.just message 1L Mario Luigi pasta. Okay, I just want pasta. That's all. Just give me one pasta. You can do like, you know, message 2L from Luigi to Mario. No, I'm very hungry. I can smell the pasta and meatballs. Okay, so the next, private, that's not right. That shouldn't be a private. All right, so the next thing we want to do is, all right, so what do we have here? Yeah, all right, so we have our two things here. And now we want to test a web endpoint. So what I want to do is I want to expose and slash all. So let's do that. Let's do fun. Should get all, right? Okay, that's all it's going to do. It's going to return all messages. And then what we're going to do is we're going to tell, we're going to use reactive. We're going to use reactive in order to connect to the web. And how do we use reactive to connect to the web? Something called web test client. And in order to test the function we're going to test, we're gonna say bind to a router function. So binding to the router function. So I'm going to create my own router function here. Okay. So let's create a class called WebRouter, extract it to a separate file. There we go, WebRouter repo. Okay, so what had happened here is we just have a simple class, and what does it do? It's a component, it's a configuration component. Probably doesn't matter that we create it as a configuration component since we will bind to it directly anyway. But for production, we're going to want it to be a component. The next thing we want is a bean name. And we're going to say fun route, and it's going to be a server response. Oops, server. Yeah, it's going to be your server response of oh gosh, something of a server response. Router function. Oh, gosh. Well, that was weird. Okay, so what we want here is a router function of the server response, and I'll show you what that means in a second. Okay, so this function is a router function, and what it does is any router function can be found on the class path as beans, right? And a router function allows us to, given a predicate, an HTTP request predicate, that says something like get, then it needs a URI as well. So what is the URI? The URI here is /all, right? Okay, so that's our predicate. Now in Kotlin, we have this really nice syntactic sugar where at the end of every method, if it's a function, you don't have to put it in parentheses. That's why we have router. And that's why get does this, because the get predicate has a parameter in which its function's a lambda. And that lambda says, hey, I'm going to give you a server request. Now, what we want to do here is we want to say server response. We want to return with server response. We're going to return it with a string here. Dot. Oh, come on. There you go. Dot, okay. So we're going to say 200 okay. Dot, and then body. And repo dot find all. And then the message class dot java. Now that allows Kotlin to, hi, val repo. There we go. Is it colon class? No, yeah, it is. Okay, my bad. All right, so what just happened here, Maria? That doesn't look like Java at all. It doesn't look like Java that much, I would admit. But this is a DSL. And this DSL takes the premise that Kotlin allows you to omit parentheses in a function call as long as it's a function that's being called. So if you notice, routes is the only function here, and it's a router function DSL that returns unit. And that's it. And that is given, this router function DSL takes a predicate. And this get here, just like that, is another function. So it returns something that gives us a function, a mono of server response. So server response, okay, body, is going to be a mono of a server response at the end. But it does take the flux and it does turn it into JSON. So it's really, I guess, functional in this case. We can do bind and then we can do build. So now we have an instance. Now we have an instance of our web test client that's attached to our server, right? To our server function, our router function. Now we can say get, and then, wow, I am deleting everything. URI /all dot accept media type dot application JSON dot exchange. So this is going to build a server request, a virtual. It's going to build a virtual server request, a server request, and then it's going to exchange it for a server response at this point. And now I can ask it questions about what happened. So I can say expect status is okay, and then I can say expect header, and says content type is media type dot application JSON. And then for some reason I want to expect the body, and then I can say JSON path, and you've probably seen me do this or somebody else do this. So JSON path looks like XPath, and it allows me to write these really cool expressions. Oopsie. My bad. I'm not giving it arguments. There we go. Whoa. Completely ignored that, didn't it? Okay, so what we want to just make sure the first element is 1, and it has a equal to from Mario, which is true here. Yeah, from Mario is 1. Okay. Don't worry about anything else. From this point on, where it'll execute, and it'll create a decision script for this, which is really cool. It's a really cool item to use. Now let's go ahead and execute this test, and then move on to the contract part. Okay. So hit terminal. Alrighty. So, excuse me here. Please tell me that's not visible. Okay, maybe that is visible. Alrighty. Yeah, so it looks like it failed, which is probably because, where did it go? Where did it run? Here's my run. I know I failed something. Oh, test just ignored. Before all. Yes. Static. Yes. My bad. I knew it was that one. Before each. I don't want before all. Otherwise, I need to use a test distance life cycle static. It's just an extra code of a line of code to add. And who really wants to add a line of code? How do we? Can you like? There we go. My mouse pad. Okay. So the next thing I'm going to do is I'm going to take this web instance and then I'm going to write a contract about it. And then I'm going to take that contract and I'm going to build a stub that resembles my service, right? So let's do that. Let's write a stub that resembles our service. But before I do that, I need to engage a couple of things. The first thing is, in order to write the contract, I need to know what I'm going to write the contract for, and I need to introduce you guys to the POM file augmentation that I'll make. So I'm going to change the POM file here. And I shall find a terminal and just give you guys a good, hello, you're there. Let's go into our workspace and let's say Bootiful testing. Let's go to one of my previous examples because these things can be very large. Now let's say, let's look at the last thing I did here, service, say pom.xml, and grab that. So there's quite a bit of XML here that I tend not to remember. I know where it is. I guess that's kind of important, but I'd rather just copy and paste it if I could. And I find that usually works out just fine enough. Okay, so what we have here is a plugin. Did I just take the wrong plugin, you guys? Yeah, it looks like I did. There we go. Yeah, okay, now that's a little bit better. So this is a Spring Cloud Contract plugin. So the Cloud Contract plugin allows me to say, contract name plugin. Something is wrong with this. Where's base class? Oh, that's not right. Oh gosh. Why is that? Yeah, that is not right. Sorry about that, you guys. That should probably crash. Let's get out of there. Yeah, that wasn't the best one. Service POM. Here we are. Okay, usually I have it in a paste bin. Actually, I probably do still have it in a paste bin, but alrighty. So we have a Spring Cloud Contract version I gotta fill in there. But basically what happens is this guy needs to be told how to create stubs. I'm gonna tell it how to write, how to create stubs. And so the first thing that I want to do is put in comdemo javafest test, comdemo javafest test base class. So base class is going to be the thing that is the parent class to the test itself. So I'll tell you what the base class really does. Let's go into Spring Cloud Contract version, and I'm pretty sure we don't have a version here, right? Yes, I know. I think I used 2.1.0 last time. I could have used a different version though, or perhaps I have a version that I'm going to advise to myself to use. Don't use developer versions. Developer versions tend to get you in trouble. You tend to end up on things that you might land on a release that doesn't actually work tonight. So maybe that's probably I'm being a little cautious right now, that's all. I just don't want to land on something that doesn't work. So, okay, that'll take a second to resolve itself in IntelliJ, but so what we're going to do now is write a simple base class. Oh, I got the class path wrong there. I'm done with Java. First service. I wish it was test, but that's okay, everybody. It's okay. We learned. I learned, actually. I just learned right now. If you want to talk to me, if you want to talk to me later on about my naming convention, my packaging naming convention, we'll have that chat. Class, base class. This is going to be a slightly different type of test, you guys, because what's going to happen is this is going to be a test that ultimately backs a contract. It'll have to spin up my web server. It'll have to have some representation of data, which is like a mock bean, of course. And then it's going to have to answer just like the servers did, just like my regular web test did. So what we can do is I can actually grab all of the stuff here out. I can grab that, and then I can put it into our base class. Actually, I'm going to program our base class in Java for a second. I'm going to see if that works. So what we're going to do is call it base class in Java. And yeah, we'll add that. And no, it doesn't. It usually asks, hey, do you want to turn this from Kotlin into Java? But no. Okay, so all that I did here is tell it how to, this is in Java, this is going to be overridden by a script generation system that I'll show you in a second. Now, yeah, so I'm sorry about that. Let's go for it. It's a Spring Boot test, and say web environment is random. So what we're going to have to do here is, in order for this to work properly, we need to tell the test harness that we're going to spin up a web server on a random TCP port. And I need to know that random TCP port. And that random TCP port is reported as a discrete variable in the Spring context that you can grab using this local server port here. So it's this local server port that'll, once Spring starts its web context, it'll tell us what that local server port is. So that's just a little brief explanation, but so I'm going to say private private, I think it's an int port. Most ports, there's only 16 bits, unfortunately, in IPv4. It could be a long. I don't know though. I don't think it does that way though. I hope not. All right. So it looks like we have everything we need to create the scaffolding of a test. But what's going to happen here is Spring Verifier uses rest assured. So it uses rest assured for actually running the tests. So it runs the test in rest assured. And what we need to do is we need to tell it I think that works. No, believe me, it's only 12:43 here in LA, California, where I'm streaming from. I'm near the ocean, and the last time I saw an HTTP address, I could have been sure that it looked like this: http:// hostname :port / URI. I could be wrong. I can be wrong. I've been wrong before, but I might not be right this time. Who knows? We'll find out. I'm only an American. Okay. Let's see. I have the message repository set up. I have everything here set up. Now, okay, guys, this is where magic happens. Now, I don't like saying that word because I'm of the age. I'm of the age of when things were going on in the early 2000s, and there really was magic. The Ruby language was doing things nobody knew what was going on. The virtual memory manager was always swapping pages, and we just had one instruction. We didn't know why that was happening. And so that was the magic that I'm used to. And I don't want to instill that. I do not want to instill that sort of egotistical, I can run anything, on you guys. That doesn't make sense in computing. I mean, it will when AI is a huge thing, but right now it still doesn't. So in this case, all that we're getting is we're taking that base class and we're creating another class on top of it, and we're saying, okay, well, this guy is going to call his server, and that server better have the correct response, or else. And if you believe that I forgot something, you would be completely 100% right. I did forget something. I really forgot a big part of this, didn't I? Yeah. All right. Mario forgot nothing really. Don't worry. We're in this together. And I believe that the part that I just left out is a small, tiny, itty bitty component. And don't worry, that's fireworks outside, not people blowing up the Capitol. There we are. Where are you? Oh wait. Oh my gosh. Oh my gosh. That shouldn't have worked. Yeah, but that just shouldn't have. Oh, and it did not work, you guys. The reason why is because I had no contracts in there to back it up. And this is where TDD can get you like in a place, in a kind of a bind. But if you make it part of the formal verification process to see that you have these things emitted, then it could take it away for you. But what I'm going to do here is I'm going to say I need a YAML file, and I need to actually create the contract. I forgot I forgot the most important part. The contract. Okay, so this is the contract. This is what it will look like. We're going to have a few fields. Good Lord, that's a lot of fields. Let's go ahead and hi, code. Where are you? I need a code window up. Okay, there we are. Now we have a code window up. Okay, now I can read. So I have to describe a YAML file. So allow me to describe this. It's simple. Description, return all messages, name all messages, request. So we'll describe request with the URI, and then we'll say method get. Okay, and then we'll describe that response has a status 200, headers, content type colon. I guess it's going to be application JSON. Application / JSON. There we are. And then I need an actual JSON file to give back to the service. So this contract says, hey, you give me a request, I'll give this response, but what's the body look like? So I can say body from file .json. So I'm going to create a body of a file called generic.json. I believe that's correct. Next colon file generic.json. There we are. All right. Yes, add it to get. But that's that's my bad. Okay, delete that. Say new file. That's better. Yes. Okay. So what does it look like? So it looks like that, right? And it has ID 1 from Mario to Luigi. If you write JSON like that, man, body, pizza. Okay, because today is pizza, or maybe even pasta. But I'm more of a pizza person, so you could take pasta any other day. How about pasta? Okay, I'll stay at pizza. Alrighty. Now we have that. Now make sure that's syntactically well. Let's go back to our base class. Okay. Notice we have 2 of them, so we're going to need to actually make the first one pasta because that was the correct answer. So it's going to be pasta, and then that JSON is going to also have a second element in it, right? So it looks just like the stuff that we gave it earlier. So it's going to be from Luigi. And then that's going to say Mario to Mario, and it's going to be meatball. And I hope that's not camel case, because otherwise you're just sadistic Mario. Okay, so we have 1, 2, Luigi, Mario, pasta, and meatball. Yummy, yummy, yummy. Okay, so what's going to happen is this is going to define what better actually show up in front of us, right? The generic.json is actually just a piece of JSON that's going to get emitted as a part of the result. So it just better be syntactically correct JSON. So let's go ahead and run this again, right? And because we're going to run it again, we're going to take a couple of seconds for all the stuff to get compiled and figured out. Now let's see, what have I done so far? What have I messed up on? Right, so I created the contract. I have a base class that backs up my contract, or all of the contracts, right? Now because I created that contract will get transpiled, right? So remember, a little bit of transpiling happens. It turns that YAML file into a rest assured test. That rest assured test subclasses my base class. So my base class needs to essentially operate like I asked it to in the YAML file. And this is a kind of important step. I would typically, yes. Oh, 1 second. Alrighty. So let's make sure that works. 1 more minute, and then I'll take QA. What's going to happen is this contract is out there. It's going to be installed somewhere. Oh, okay. I know what else. Right. Hi. There you are. Now, the reason why that didn't work was because I need to add a base class, but that's fine. You can still find the test source code on the GitHub, and everything will be there for you. Now, I could take QA at this point. So if you guys ready? I am ready. Hi. I can't hear. Why can't I hear?
Hello, do you hear me?
Yes.
It's Kiev
Do you
calling.
hear me? Oh, okay. Is it echo?
It's a bit echo.
Oh, let me turn it down. Okay. There you are.
Yeah. Okay. It sounds great now. Okay. Thank you for your talk. And I told that I got really hungry while watching you live coding with all the pizza and pasta and all this stuff. So now
that was the idea. I needed. Mm-hmm.
Yeah. Now we will ask questions from the chat. So dear participants, please write your questions to Mario to the chat, and I will ask them. We should wait a bit while guys are preparing their questions. Yeah,
Okay.
looks like your live coding was so intense that guys are not ready with the questions right now.
Did they fall asleep? Oh
I
man.
hope
Okay,
no.
look, if anybody falls asleep, okay, look, just don't fall asleep. You guys will be fine.
It's early
I
morning
try
in
to I try to
Kyiv,
make it.
so no.
Oh, good. Yeah. So it's live coding Saturday in the morning. That's perfect. That's like Saturday morning code cartoons. We need that. I'm really glad to have been part of this. Thank you for putting this together. I think every time I do this, it's awesome. I love your presentation and your motif and art direction is amazing. Thank you very much for having an awesome show so far.
We're glad. Okay, guys, if you have questions but you can't formulate them right now, you can join our Zoom room with Mario after the talk. Just join 2 minutes after the talk and ask your questions to him. Thanks a lot, Mario, and have a good night in California.
Thank you. You too. Enjoy your day and evening.
Yeah, thank you.